Good afternoon, everyone, and welcome to this TEWI Kolloquium of Farzad Tashtarian. He is a postdoctoral researcher at, as you can see, Department of Information Technology in the context of the Athena project. And he will give a talk about how to optimize dynamic adaptive video streaming, and he will point out some challenges and solutions. Welcome, Farzad, and please go ahead.
Yeah, thank you. Thank you, Christian, for your introduction. Hello, everyone, and good afternoon, and thanks for being here for my initial talk in a habilitation process. As you know, this talk is about how to optimize dynamic adaptive video streaming challenges as solution. I hope to convey useful information about this topic at the end of this meeting. Just one slide about myself. I'm Farzad Tashtarian. As a postdoc researcher here, I've been working on Athena project that is about adaptive streaming over HTTP and emerging network multimedia services. Before joining Athena and working here, I was assistant professor at Azad University of Mashhad, Iran. Athena project is funded by University of Klagenfurt, Christian Doppler Research Association, and Bitmoving Company. In this talk, we have different topics here. The first one is an introduction on dynamic video streaming, and then we have a proposed layer architecture, and some interesting questions will be answered. For example, where to be optimized. We define input space and action domain, and then an introduction about the Lalisa recent work we did here, and future work, and followed by conclusion. Let's take a look on some statistics that shows how much video streaming is very popular for these decades. For example, Cisco reported that more than 80% of traffic in the internet is about video streaming. And YouTube stated that over 2 billion monthly active users who start streaming for over 1 billion hours of video every day. And Netflix also mentioned that more than 200 million subscribers globally over the globe. Amazon also has very interesting statistics, 1,055 million subscribers in 2021, and with over 200 million hours of video content streamed every day. And Twitch also is a platform that hosts many users. For example, 13 million daily active users that watch over 1 trillion minutes of content. It's very remarkable and interesting statistics to show that how much video streaming is popular. And undoubtedly, we know that the video streaming was a great help during the pandemic and Corona. From a financial point of view, we have a good progress in financial matter. For example, here, global video streaming market was valued at 50 billion and is expected to reach 184 billion by 2027. So, here's some statistics about the video streaming. So let's start by having a simple demonstration of video streaming. Assume that we have one origin server here with outgoing buffer and some contents that already at the ongoing buffer. And here we have our clients player that want to start streaming. And then we have the first segment that goes through the internet. Internet here fluctuates. You can see the fluctuation sometimes happen in the internet, on the internet. So the first request came to the origin server, and the first segment received by the client and put in the buffer. Then we have a next request by the client, and because of the network fluctuation, clients decide to request for the lowest quality because we have different qualities, base, medium, low, and here clients request for the low one. And we have another request and another request, but as time goes by, we have a better quality because of the buffer that we have. At this time, maybe at a specific number of segments, clients start rendering. and consuming the segments in the buffer. But the interaction between the clients and the origin server is continuing, and request and response. But behind this story, we have many components to provide this valuable service for the clients. You can see here we have live video source or video on demand, no matter which one, we can have it for this example. We have some equipment here to prepare content for all users over the globe. So we have network here, that network core and network edge, different component on the internet, CDN network. And we have at the end, we have players. So we name it as a video contribution up to reach to the network, and then we have a video distribution to distribute the segments to the users, and we have video consumption or consumer, that actually the user that starts streaming. Before this talk, I was thinking about how to present the things about the video streaming, the challenges, the approaches, the different elements that we have in the video streaming. And I decided to come up with this structure here that cover anything about the video streaming. We have application layer or video streaming application layer at the top, and middle we have management and control layer, and in below we have resource layer. Any approaches, any ideas about video streaming should place in this structure, I think. So in the first layer, we have video streaming applications. Different companies provide different production about the video streaming. Regarding our research here in Athena, we have two main categories for application: video on demand and live video streaming. And for each, we have subcategories. For example, for VOD, we have entertainment and education. And for live video streaming, we have different categories of events or news, gaming, different things about the live streaming. Another thing that is very important to consider in this layer is their requirement. But before that, let's take a look on the some statistics about the live streaming. You can see here live sport with 19% in this pie chart stands the first rank, and then followed by the conference and trade shows and conventions. And we can see that here there are many applications. For example, user-generated content with 7.5% of this space of live streaming. So it's very important to cope with these challenges in live streaming. Here we need to know about the requirement that this application needs. For example, the quality. The terms of quality refer to the overall visual and audio experiences by the user during the streaming that consists of different parameters. For example, resolution, bitrate, frame rate, and audio quality. The next one is latency. Latency in live streaming defined as the time between the first scene that captured by video until this event or this scene watched by the user at the end site. We have this latency. For the latency, we have different ranges. For example, here we have near real time, that the technology, protocols, and equipment that we need to provide this in terms of the latency is totally different. For the near real live that is less than 1 second, for example, we have WebRTC as the main and predominant protocol to provide this application. But when we increase the time, for example, for the common HTTP latencies, today we have applications about 20 seconds. Each one, as I mentioned, that each one has its own protocol, its own requirements. Then we need to know about the resources, how much resources this video streaming and application needs in terms of the computation, storage, and bandwidths that they need. Reliability is another metric that we need to consider during the designing solutions for video streaming. Reliability means that the consistency of delivering content to the user without any, drop or switching a lot between the qualities. It includes different items: stability and performance of the video player, availability and quality of the video content, and responsiveness of a streaming service to the user, to user request. And last but not least is about the scalability. The scalability means that how much this application should handle user over the globe. That is very main challenge for us to propose a solution that has good, useful and in the terms of scalability. The next layer about the management and control layer. Any ideas about the video streaming, we can put it here in this layer. First one is a streaming policy. We need to know about the streaming policy, which solution we have for serving clients. We have different policies to serve clients. For example, upon receiving requests, we can fetch from the origin, or we can serve with transcoding, is another function that translate or do some changes on the segment and then send to the user, or we can serve with a lower quality. Then we need to have a module or a box for QoS and QoE control. During the time of streaming, we need to control QoE and the QoS. Different metrics we have, and we need to measure. For example, for the QoE metrics, as a quality of experience, we have quality, bitrate switching, stall, and for QoS metrics, we have delay, jitter, and packet loss. Anything that related to these main components should be monitored during the streaming. How to calculate them? We need to have some feedbacks from different elements of the network and different elements of the streaming path from origin to the clients. So, for that reason, we have application statistics collector. That this box is responsible for collecting different things from applications, from resources that we have. And there are different options that we have. In industry, for example, we have deployed analytics server that continuously gather information from clients to keep track the activity and during the streaming. Or we can use CMCD, that stands for Common Media Client Data. We can set this tool for gathering information from clients. We have another box here for the resources. During the streaming, we need to keep track all changes during the streaming over the resources that we have. Different tools here, for example, network performance monitoring or NPM tool, or different tools here, we can use them. Any action that this layer taken should apply on the network. With which boxes? We have two boxes here, task assignment and resource allocation. Let me give you an example for this. For task assignment, we can, for example, launch a task of transcoded or encoding over a cloud. And then for the resource allocation, we need to allocate enough resources for a specific function that we need to run for the streaming. Any communication between these two boxes in the management and control layer should take place here. Video streaming controller and optimizer is the brain of this management and control layer, and is responsible for all communication between these boxes and determine the good solution for the challenges that we selected. The last layer here, resource layer. We have our resources that we need for video streaming. Computation, storage, computation for launching some process and programs, for example, encoding, transcoding, different things, storage that we need to store some segment at the network edge to serve clients, and bandwidth that we need to send segments to the user or receive some requests from them. Okay, by having this structure, we need to answer to this question, where to be optimized regarding this path of this streaming. Where to be optimized? Here, let's visit this slide again. For video streaming paths, we have the content here to the end user there. So researchers think about the different part of this topology. For example, some work on this space of client side, work on the ABR. Some researchers like to work on the edge network or network edge, just about assigning online transcoding, serving strategy, optimize something here. Some work in CDN network, but for us as a researcher here, just CDN network is a black box for us. And some companies that support this network should propose some good idea for increasing the performance of this network. And cloud network, some researchers just select this area to come up with a good idea about the video streaming. And the first step in this path is about the encoding process, is about the different process that we need to prepare data for the user, just about the origin side. Which place we can select for optimizing. So if we select some part of this path, we need to propose a local optimization, approach that locally optimizes somewhere. We have some merits and demerits for that. For example, we have, if we select a part of the network to optimize, easy deployment is the first advantage of that. We can just consider that equipment on that place and we can optimize that. Access to the required local input variable, we can easily access to them. Apply action on considered elements. And low computation time compared to the global solution that we need to consider many parameters. But main challenges here is the local extrema that maybe is just local local optimization, not the global one. So we need to consider a bigger box over the all equipment, end-to-end optimization. If we want to have this approach to propose something about the end-to-end optimization, we need to consider different variable parameters from all elements on the path from the origin to the client, and it's very difficult. We have also here some advantages and disadvantages. In terms of the advantages, having a holistic view of the network is very useful for us to keep track all activities between the elements and between user and then between the different agent component and different things. And having end-to-end approach is very useful because we can optimize anything on the whole path, not at this specific segment or part of path. But we have many challenges here that, for example, high computation time. How we should tackle with the computation time or time complexity of the solutions. Difficult deployment. We need to have more inputs. Actually, we have, but not real time. We have some information from analytics servers, but not at the same time, the real time. We have them after, for example, 10 seconds. It's not real time. We have some information from cloud, from CDN, but maybe after a couple of days. It's not very useful for us. So here we need to have our own approaches. For example, we can apply CMCD or analytics server, but the time is very important for us. And here, because of the global solution and plenty of variables and components that we have, we need to employ something like SDN or software-defined networking architecture to the overall solution that we have. Okay, let's answer this question by two questions. Which parameters should be considered and which part should be affected for this solution? For these solutions, we have something to present here. For example, we have input space that gather all parameters that we can consider for our solution. And also we have action domain. Action domain is all parts that we can apply anything on that component or that part of the video streaming path. For that, I summarize all parameters here. For application layer, we have content, for example, content complexity, we have quality of experience, user preference, required latency, resources, scalability, availability, different things for the application. Which one do you want to consider for a solution? And also for the resource layer, we have some parameters. Available resources, for example, computation, storage, and bandwidth that we have. The performance that the network already has for the serving streaming, and the network quality of service and cost that we need to pay for our live streaming. These, we can say that all parameters that are very important for us to consider and take into account for proposing an approach for the live streaming. But having these parameters and solution, okay, which part of the network or which part of the path from the origin to the player should be affected? We have different parts. We have for the video contribution, we have per title encoding. For example, we can select or do something for these main variables here, encoding parameters. We can apply the solution on bitrate ladder, segment size. For the video distribution, we have some parameters that can be selected for as an action domain here, utilization, cache management, function placement as a virtual network function that we can run over the network, multi-path data transmission or data pass between different things. We can apply our solution on these parameters. And about the video consumption, ABR algorithm design and different idea about the super resolution or something else. We can have this as an action domain. These two main rectangle here will be connected by the solutions. Solutions connect and map and consider this input space and apply action on the action domain. So here, for example, some works just consider content complexity and apply on per title encoding, but it's not end-to-end. It's just from the content complexity of the application layer. If we expand our solution and action on this rectangle, so we can say that we are in the way of end-to-end approaches. In some works, we have network quality of service consider and then also content complexity and do some actions on bitrate ladder. So we have categories of solutions here. Based on research that we did in Athena, we have some mathematical optimization for optimize some part of the network. We cannot claim that all our solutions are end-to-end, no. Just part of the network or part of the streaming path optimized by some work. For example, here we have mathematical optimization. We can use this solution that the main challenge is time complexity issue, specifically when we need to have them for the live streaming. And so we can have some solutions for distributing this solution, this mathematical optimization over some nodes as ADMM that we applied for some studies. And then we have meta-heuristic that is very useful approaches for coping with the time complexity of the mathematical optimization. For example, simulate annealing, evolutionary algorithms that are useful for us to have them. And machine learning and AI techniques is very useful. As you know, here we have plenty of techniques for applying on different challenges, different issues, useful techniques for real-time application, somehow accurate in these predictions and suitable for distributed solutions. That we use these techniques in some studies. So here we selected one of their recent work. Lalisa is about adaptive bitrate ladder optimization in live streaming that accepted by conference NOMS. And we selected because we are working on this idea, and we try to submit our next version for the next conference. But here we can start with this topology. First, take a look on some preliminary of the concept that we have. For the live streaming, we have origin server there. And with the camera, we have some contents from camera to the encoder software or hardware encoder that based on the fixed bitrate ladder, we prepare segments in different quality and prepare them for the user at the end. Then this content goes through the network and put in some CDN server. CDN servers we use for better reachability and better time for between when we request a segment, when we receive a segment. So we have this CDN server in different part of network and close to the user, and then user, based on the network and different parameters, select different qualities. So here different companies use a fixed ladder for the live streaming. There are some ladders here. You can see a bit moving. Just use this one for the ladder that encoder should follow this ladder to provide segments. Here we define this problem. How to optimize the bitrate ladder in the live streaming regarding the content and network condition, fluctuation of the network, and user demands. Actually, we try to have end-to-end idea for this, end-to-end solution, because content, network, and user, three main elements. So here we can see in this chart, we can say that, okay, here Lalisa, just consider content complexity. Scalability is one idea that one important parameter that we considered in Lalisa, and the resource, we consider these resources, and we apply the output on the bitrate ladder, and the utilization also affected by this idea. So, first, what's the difference between the selected bitrate and desired bitrate? Selected bitrate, that bitrate that the client select for the CDN from the CDN server, okay? But here, to explain the difference between desired bitrate and selected bitrate, take a look on the player. That in player we have ABR, the brain of the player that select the segments, which segments should be downloaded. In this ABR, in this algorithm, we have an ABR objective function in abstract, ABR objective function that consider buffer and bandwidth, for example. And then this ABR select a value between min and max, BPS or bit per second. Let's say here x equal to 1.8 megabit per second is the selection of the ABR, is objective ABR. But here, when client connect to the CDN server and start streaming, first client receive a manifest file. In the manifest, we have some bit rates based on the bit rates that the administrator or the content provider set on the encoder. We have this only bit rates, but how about this one? ABR select this, but ABR has to select one from here. So ABR select the closest one. No this one, just this one, because it can guarantee for the bandwidth fluctuation. So we name it here. Desired bitrate is this one, but selected bitrate this one. Okay? Let's continue with the motivating example. In this motivating example, we set a fixed bitrate ladder here, okay, with this bitrate ladder, and we are going to send the content to the 450 players, for example, here in this example. As you can see here, based on our motivating example, 50 players select 4.3, this one, and 80 players select this one, and 150 players select 1.5, 120 players, this one, and the 50 players select the lowest one, okay? But when we take a look on the details of the request, we saw that, okay, the 50 players that select this bitrate just select this one as a desired bitrate. That's good. But here, 80 players select, from 80 players, 51 selects 32. It means that upper than 3 megabits. And 30 players select exactly 3 megabits. But here, we have 50 players select 2.5, and then for 2 megabits and 1.5. We have this desired bitrate for the players that selected bitrate to 0.7. Okay. By having this information and also the quality of the content at this bitrates, we can see that here we use VMAF. VMAF stands for Video Multi-Method Assessment Fusion. That is full reference video quality metric. We can use it for specify the quality of the segments. So here you can see that the quality at different bit rates, we have different qualities. It's not linear. It's not linear, and we cannot predict the quality very accurately. But there are some solutions for that to let us have a good prediction of the quality. So by having these qualities, if in Lalisa we change the ladder to this set of values here, or here with the length of 4, or here with the length of 3 or 2, we have some gains here. Which gain? For example, in terms of VMAF, if we consider fixed ladder that's selected by at the beginning of this motivating example, we set this ladder. In this ladder, we have average of VMAF and bandwidth that we need for each client based on the request. But here, if we increase, if we have this same length of the fixed ladder, we can, provide better quality with a little bit more bandwidth. More bandwidth means more cost. And here, you can see here, for example, when we set length of the ladder to 4, we have better bandwidth consumption and better quality. It's something that is about to make a trade-off between quality and cost. We can have more bit rates, more quality, more cost. Less quality and less cost. So in this motivating example, we showed that how we can make a trade-off between the quality and cost. So another question that we should answer here is about how we can have this desired bitrate. We can use CMCD approach. And here we can see that when client send a request to the origin server or CDN server, we have this CMCD variable here, for example, desired bitrate concat to the URL of the request. So the Lalisa architecture, here we have main component, Lalisa analytics server here, and we have Lalisa origin agent here, just to apply some ladders on the encoder. We have also some CDN servers, and also here Lalisa player agent. We put a plugin inside the player to send the desired bitrate through the CMCD to the CDN server, and then we have CDN logs to the LA server, and finally we have a optimal bitrate ladder. So here for the agent part, we try to modify .js and put some codes to extract the desired bitrate, because we have desired bitrate during the selection of the bitrates. Here is a demonstration of the communication between different components, LO agent, LA server, and the LP agent. For the LP agent, we have segment number, selected BR, desired bitrate to the LA server, and then LA server send the optimal ladder if LA agent decides to change the ladder. And from the content, we have predicted VMAF values from the content that continuously and periodically is sent to the LA server. But here in LA server, we need to run some mathematical optimization to select the best or select the optimal ladder. Here, we designed the formulation as follows. First, maximize the quality and bitrate, a function of the quality and bitrate. Bitrate means about the cost and the quality. We need to maximize this by this formulation. Regarding some constraints, for example, each request should be served with 1 bitrate, is the one constraint. Maximum generated data regarding selected bitrates should be monitored and measured, as here as B. Amount of VMAF improvement by serving desired bitrate, and amount of VMAF degradation by serving with lower bitrates. If we ignore to provide that selected bitrate, that desired bitrate, we need to serve client with a lower one. So we have another parameter here, constraint to limit the length of the ladder, and we have the variables. This formulation, let us have this formulation for the live streaming. We could apply in the live streaming because of the complexity of this model is just about the number of the bit rates, is not about the number of clients. So we can apply this formulation on the live streaming. About the testbed, we use Lalisa. We use Catwise. Here is the one of testbed that we used here with the AWS Amazon instances. That about the segment duration, we consider different segments duration, about 120 seconds of the experiment. Network traces 2 main networks, LTE for all players and also fixed at the origin site. About the codec, we use 264 codec. About the content, we consider animation and different number of players. And we compare the Lalisa with the ladder with a different, ladder. For example, for a ladder with 4 values here, and with 9 values and with 22 values of the bitrate inside the ladder. Here you can see in terms of the these 3 lines here shows the ladder that we selected to compare with. And for the different columns here, you can see that, for example, Lalisa with maximum 2 bitrates in the bitrate ladder, or 4, or 6 and 8, and also 10 bitrates, but with different maximum bitrate inside the ladder to have a fair comparison between the Lalisa and other ladders. For different traces and different number of clients, we can see that the average QE score is almost same. And also here, for the average of VMAF, you can see that here when, for example, use the Lalisa with only 2 bitrates, we have some drop in the VMAF. But if we have the, for example, 10 bitrates, we can reach to the fixed bitrate ladders here. But in terms of the cost, we have good, outcome and good gain from here. We compare the Lalisa with BL9 here. You can see this BL9. And for different, lengths and maximum, as here, we can see that this is a maximum, and we see this maximum here. With different bitrate ladder size decrease, you can see here. For different ABRs, we can see that if we have a large or a longer ladder, we have a better performance in terms of the degradation in QE and VMAF. But when we decrease the size of the ladder, we don't have enough performance, enough good gain in terms of the VMAF for some of them, not for all. And here you can see the bandwidth cost and the computation cost saving. For example, when we have 4, 6, or 8, we have, for example, for 4 bitrates inside the ladder, we have more than 50% computation cost saving. That's all. And about the future work, we are going to extend the idea of the Lalisa to cope with the limitation, consider energy in the end-to-end live streaming, and leverage distributed ML techniques and AI techniques, and end-to-end immersive multimedia streaming could be another direction for the research. And in this talk, I introduced some concept about the video streaming, followed by the layer architecture, and in local and global approaches, input space and action domain. And also we introduced Lalisa approach here. For publication, you can just visit my website and homepage. Here I put all publication conferences and journal papers and academic services that I did during the last couple of years, and also teaching experience that I have during this time here. Thank you so much for your attention. I would be happy to answer your question. Thank you.